Never get too close to a black hole. Seriously, don't even think about it. Because once you cross that invisible line called the event horizon, there's no turning back. Not for you, not for light, not even for time itself. You don't fall into a black hole. You get erased. And here's the part no one really talks about. Black holes aren't just giant vacuums in space. Some of them tear stars apart like wet paper. Some shred entire planets into atoms. Some warp time so badly you could watch the universe age billions of years while you're stuck in a moment that never ends. And the worst part? Some of them are moving. That's right. There are black holes that drift through space like cosmic predators, totally silent, completely invisible, and impossible to stop. We've even found ones that were kicked out of galaxies after a massive collision. Now they just roam, alone, looking for their next victim. Could one be heading our way? We have no idea. These aren't just strange space objects. They're physics gone wrong. They break our understanding of time, gravity, even reality itself. They hold the answers to the biggest mysteries in the universe, if we can survive long enough to study them. But today, we're not just talking about black holes. We're talking about the most terrifying black holes to ever exist. The ones that don't just bend space. They break your sense of what's possible, and they're real. Black holes are already some of the weirdest, most terrifying things we know about in the universe. The idea that something can be so heavy and so dense that it literally breaks the laws of physics is already hard enough to wrap your head around. But what's even crazier is, that's just the beginning. Some black holes are small, silent, and sneaky. They're just floating through space, completely invisible, waiting for something, anything, to get too close. Others are so massive, so unbelievably huge, that they could swallow entire solar systems without even blinking. And then, there are the ones we're not even sure are real yet. The ones we've only seen hints of. The ones that, if proven to exist, would flip everything we know about space on its head. See, we used to think black holes were rare, special, but now we know the truth. They're everywhere, scattered across the galaxy, hiding in plain sight. Some sit quietly at the centers of galaxies like cosmic time bombs. Others move through space, completely untethered, like predators with no leash. There's even a chance that black holes formed before stars did. And if that's true, we're talking about objects that have been around since the beginning of time, lurking in the dark, older than light itself. And what makes them terrifying isn't just what they are, it's what they do. They don't just pull you in. They stretch you out, crush you down, and erase your existence from the universe. Once something crosses the event horizon, the point of no return, it's gone. Forever. Not even light can escape. Not time. Not matter. Nothing. And yet black holes don't just destroy. They shape galaxies. They warp space. They bend time. Some scientists even think that every black hole might hold another universe inside of it. Which means we could be living inside one right now. So the question isn't just, what are black holes? It's, which ones should we be afraid of? Because when you look closely, some of them don't follow the rules. Some are growing too fast. Some are too big to exist. Some are moving when they shouldn't be. Some are missing. And some are headed straight for us. In this video, we're going to break down the most terrifying black holes ever discovered, or even imagined. From invisible assassins to gravity wells that rip apart time itself, we're going to explore the darkest corners of space and the monsters that live there. By the end, you won't just understand why black holes are scary. You'll realize just how little we really know about what's lurking out there in the dark. Because space doesn't just have black holes, it is black holes, and we're stuck inside it. Black holes aren't rare. They're everywhere. Let's clear up a common myth. Black holes aren't rare. They're not one in a million anomalies floating out in deep space. They're everywhere. Seriously. Astronomers estimate there could be millions of them in just our Milky Way Galaxy alone. And here's the part that makes your stomach twist. We've only found a tiny fraction of them. Most black holes are invisible. They don't glow, they don't shine, they don't give off light. Unless they're actively feeding on something, they just drift, silently, hidden in the dark. That means some of the most dangerous objects in the universe could be right near us, and we'd have no idea. Some black holes are calm, quiet, sleeping. Others, not so much. Some are constantly growing, pulling in gas, dust, and even stars. Some are part of violent galactic collisions, smashing into other black holes and forming bigger, meaner versions of themselves. And then, there are the rogue ones, black holes that have been kicked out of their galaxies and now drift through the cosmos like assassins. No warning, no sound, just pure gravity. And the worst part? We don't know where most of them are. We can only see the loud ones, the ones that scream with radiation. The rest are just shadows in space, warping time and light without leaving a trace. So no, black holes aren't rare. They're just very good at hiding. And the ones we've found, the ones that do show themselves, some are so massive, so bizarre, so terrifying. They make you question if we really understand anything about the universe at all. Get ready, because what you're about to see will change the way you look at the night sky forever. Stellar black holes. Small, silent, deadly. Let's start small. Not tiny small, but small compared to the terrifying giants you'll meet later in this video. A stellar black hole is born when a massive star dies. And I'm not talking about your average star. The one that becomes a black hole needs to be at least 8 times the mass of our sun. That's the minimum. Anything less, and the star just fizzles out, becoming a white dwarf or a neutron star. But when a star is too massive to go quietly, things get violent. As long as a star is alive, it's basically doing a cosmic balancing act. In the core, it's burning hydrogen through nuclear fusion, pushing energy outward, holding up against its own gravity. That balance keeps it stable. But eventually, the fuel runs out. And when it does, there's nothing left to stop gravity from winning. It's like the star suddenly gives up and collapses in on itself. Now imagine this. Something the size of our sun, or much bigger, gets crushed down smaller than a city. Its core shrinks so much that the atoms themselves are squeezed past breaking point. Protons, electrons, neutrons, all pushed beyond recognition. What's left is something so dense we don't really know how to describe it. We just call it a singularity. And here's the weird part. The math says this singularity is infinitely dense. Infinite. All that mass crammed into zero space. Not small, not tiny. Literally no size at all. It's a point in space that doesn't make sense. Now pause for a second. You started with a star that had a finite amount of mass. Not infinite. It had a beginning. It had weight. It was a thing. But somehow, when it collapsed, it created a place with infinite density. Yeah, that's where physics just stops working. Our best theories, Einstein's general relativity and quantum mechanics, both start to break down right there. Time doesn't work the same way. Space warps into something unrecognizable. Cause and effect? Forget it. The singularity is where all logic dies. We don't even know if it's real in the way we think of real. It's a placeholder for, we have no idea what happens here. But what we do know is what forms around it. Something called the event horizon. Think of the event horizon as the point of no return. It's the outer boundary of a black hole. Once something crosses that line, light, matter, even time itself, it's gone. No escape, no signal, no second chances. From the outside, you'll never see what goes in. You'll never know what happens inside. That information is locked away, maybe forever, and that's what makes black holes terrifying. They're not just dense, they're unknowable. Now, not all stellar black holes are dangerous. Most of them are far, far away. Billions of light years out there, doing their thing. Some just sit quietly in space, leftovers from ancient stars. Others are part of binary systems, where they orbit another star and slowly suck away its material, like some kind of cosmic vampire. But the scariest ones, the ones we can't see at all, Imagine a black hole that doesn't have a star nearby, no gas to feed on, no glowing accretion disk, no radiation. It's just there, completely invisible. Not even X-rays to detect. That's what we call a rogue black hole. These things are wandering through space, alone, and they don't need to be huge to be dangerous. Even a small stellar black hole has the power to wreck an entire solar system. Now let's say one of these rogue black holes just drifts into our neighborhood. We wouldn't see it coming. There's no light, no warning flare, just gravity. At first, maybe the outer planets start acting weird. Their orbits shift slightly. Astronomers notice something's off but can't figure out what. Over time, things get worse. Planets begin to wobble, spin out of control, or get pulled away entirely. And eventually, Earth would feel it too. We could get slingshotted into deep space, flung out of orbit like a rock from a slingshot. Or worse, the black hole's gravity could rip the solar system apart and suck us in, slowly, unstoppably. And if we did fall in, spaghettification. Yeah, that's the real term. No joke. It sounds funny, but it's anything but. Because of how gravity works near a black hole, the difference in pull between your head and your feet becomes enormous. Your body would stretch into a long, thin line. Every atom is pulled apart. You wouldn't be torn apart like in a movie. It would be much worse. You'd be ripped into a stream of particles. You'd die before you even cross the event horizon. But to someone watching from a distance, it would look like you were frozen, hovering near the edge, getting dimmer and redder until you vanished from view. Let's not test that theory. Now, most of the stellar black holes we've found so far were only detected because they were actively feeding. One of the best examples is Cygnus X1, discovered in the 1960s. It's about 7,200 light-years away. Not close, but not far enough to feel safe. What makes Cygnus X1 terrifying is how hungry it is. It's pulling gas off a companion star, forming a glowing, spinning disk of material around it. That disk is so hot it gives off X-rays, which we can detect from Earth. That's how we found it in the first place. If it wasn't feeding, we wouldn't even know it existed. And that's the disturbing truth. There could be millions of stellar black holes in the Milky Way, maybe even billions, and we've only spotted a few dozen. The rest, hidden, invisible, silent, just waiting. Some astronomers believe that a large portion of the missing mass in our galaxy, the stuff we should be able to account for but can't see, might be made up of rogue black holes. That means space isn't as empty as it looks. It's full of invisible traps. Now you might wonder, if these black holes are everywhere, how come we haven't seen one up close? Good question. The truth is that space is big, really big, and the odds of one drifting directly into our path are low, but not zero, and we've already seen hints. In 2022, astronomers using the Hubble Space Telescope spotted what might be a rogue black hole moving through the Milky Way. It was detected through gravitational lensing, a phenomenon where the black hole's gravity bent the light from a background star. It was subtle, a tiny flicker, but it told us something was there, that something was 5 to 7 times the mass of our sun, moving, alone, through the galaxy. That's the kind of thing that keeps scientists up at night. Even though stellar black holes are small compared to their larger cousins, they're still powerful enough to warp space, twist time, and kill stars. They're proof that in the universe, size doesn't always determine danger. Some of these black holes were born billions of years ago. Some are just being born right now, from stars exploding in other galaxies. Each one represents a place where the laws of physics break down, where time gets tangled, and where anything that enters disappears forever. We may never know what's really inside a stellar black hole. It could be a singularity. It could be a bridge to somewhere else. It could be the end of the line, or the beginning of something we can't even imagine. But until we figure it out, one thing's for sure. You don't want to be anywhere near one. Cygnus X1, the first confirmed killer, There's something unsettling about knowing that one of the most dangerous objects in our cosmic neighborhood was found almost by accident. Back in the 1960s, scientists were studying X-ray sources in space when they stumbled across a bright, flickering beacon coming from the constellation Cygnus. That strange signal didn't make much sense at first. There was no star bright enough to be causing it, at least not one we could see. But the signal kept pulsing, and it wasn't weak either. It was powerful, consistent, too intense to ignore. So they labeled it Cygnus X1, X for X-ray, 1, because it was the first major discovery in that region. They didn't know it at the time, but they had just found something that would change how we understood the universe. Because Cygnus X1 wasn't just some anomaly in the sky, it was a black hole, and not just any black hole. It was the first time we had solid, scientific evidence that these things were real. Not just math on a chalkboard or weird ideas from Einstein's notebook, but actual monsters lurking in the dark. Before Cygnus X1, black holes were purely theoretical. Scientists believed they could exist, sure, but no one had actually seen one. And technically, we still haven't. Black holes don't emit light, and light is what we need to see anything in the universe. But Cygnus X1 changed the game because it was doing something black holes weren't supposed to do. It was feeding. There's a nearby star, about 20 times the mass of the Sun, caught in a deadly dance with Cygnus X1. They orbit each other closely, like two partners locked in a gravitational waltz. But it's not an equal relationship. The black hole's gravity is so strong that it's actually pulling gas off the star. That stolen material forms a spiraling ring around the black hole, called an accretion disk. As the gas spins faster and faster, it heats up, reaching millions of degrees, and releases massive amounts of energy in the form of X-rays. That's what we saw. That's how we found it. If that star weren't so close, if Cygnus X1 wasn't actively stealing from it, we might have never known the black hole was even there. That's the part that really gets under your skin. It's not that Cygnus X1 is unusually close or powerful. It's that it's visible. It's loud. But the scary part? Most black holes aren't. The truth is, for every Cygnus X1 we've detected, there could be hundreds, maybe thousands more that are completely invisible. Silent, wandering, waiting. These black holes don't have companion stars. They're not feeding. They're just floating through space, undetectable by any regular means. And if one of them passes near a star system, or worse, near us, we wouldn't know until it was far too late. Back when Cygnus X1 was discovered, a lot of scientists were still skeptical about black holes in general. The idea that a dead star could collapse into a point of infinite density, a singularity, seemed almost too extreme to be real. But this discovery forced everyone to take the theory seriously. It was like catching a ghost on camera for the first time. Suddenly, all the whispers and legends became real, solid, confirmed. That confirmation came with a wave of fear and fascination. Because Cygnus X1 isn't just proof that black holes exist, it's a reminder that the universe doesn't care about what we can see or understand. It's not here to make us comfortable. It's full of traps, invisible traps, and Cygnus X1 is one of the few we've been lucky enough to spot. But let's talk about what makes Cygnus X1 truly terrifying. It's the mass. The black hole itself is estimated to be around 21 times the mass of the Sun. That might not sound like much in cosmic terms, especially compared to supermassive black holes that weigh billions of times more. But don't let that number fool you. That mass is compressed into a space so small you could fit it inside the city of New York. Imagine packing 21 suns into a ball the size of Manhattan. That's the kind of gravity we're dealing with. That's the kind of force that pulls light, time, and space into itself. And yet, you can't see it. You can only see what it does to the things around it. The way it bends the orbit of the nearby star. The way it strips gas like it's peeling fruit. The way it sends out X-rays that travel for thousands of light years. all from a silent predator hidden in the dark. One of the creepiest things about Cygnus X1 is just how normal it looks. From a distance, it doesn't scream danger. It doesn't shine like a quasar. It doesn't fire off massive jets. It just sits there, a hole in space. But the physics around it are enough to break your brain. Because when you fall toward a black hole, you don't just fall, you fall forever. From the outside, it looks like time slows down. If you were watching someone fall in, you'd see them stretch, distort, and eventually freeze at the event horizon, trapped in slow motion. But to the person falling in, everything feels normal, until it doesn't, until space and time rip apart and everything ends in silence. That's the thing. Cygnus X1 isn't just a threat because of what it is. It's a threat because it reminds us of what we don't know. It showed us that black holes are real, that they're not just in other galaxies or at the centers of massive star systems. They're here, in our neighborhood, 7,000 light years away. Might sound like a lot, but in cosmic distance, it's basically next door, and it's not alone. Once Cygnus X1 was confirmed as a black hole, scientists started to realize there were probably thousands more just like it. Some closer, some bigger, some moving, some maybe even heading our way right now. What if one of them doesn't have a companion star? What if it's not feeding? No light, no X-rays, just dark, raw gravity cutting through the fabric of space. That's what keeps astronomers up at night. Not the black holes we can see, but the ones we can't. Cygnus X1 also forced us to rethink how stars die. Most people think stars just explode and disappear, but that's not always the case. Sometimes their death creates something far worse, something permanent, a ghost that never fades. That's what Cygnus X1 is, a reminder that the end of a star's life isn't peaceful. It's violent, unforgiving, final. In 2021, scientists even revised the mass of Cygnus X1, confirming it was even heavier than we thought. That alone sent ripples through the astrophysics community. Because if we underestimated this black hole, how many others have we missed? How many have we misjudged? And what happens if one gets close? We've never seen what happens when a rogue black hole enters a solar system. But we have simulations, and the results aren't pretty. It would pull planets out of orbit. It could stretch or compress moons. If it passed close to Earth, the tides alone would wipe out everything. And if it came closer than that, we'd be done. No warning, no escape. Just a slow, inevitable collapse into the void. That's the real horror behind Cygnus X1. It's not just a black hole. It's proof that we live in a universe that's dark, cold, and full of invisible predators. It's proof that the universe plays by rules we barely understand. And it's proof that even in the quiet parts of the sky, there might be something watching, something hungry, something waiting. Because if we hadn't seen those X-rays, we never would have known it was there. Intermediate black holes, the missing monsters. They shouldn't exist. And yet, we might have just found them. Intermediate black holes, sometimes called the ghosts in the middle, are probably the strangest and most frustrating black holes we've ever tried to understand. They're not small enough to be the ones born from stars. They're not big enough to be the monsters at the center of galaxies. There's something in between, and the universe doesn't give us many clues about where they are or how they came to be. For a long time, scientists only had two types of black holes to work with. On one end, the stellar ones, created when giant stars run out of fuel and collapse. They're a few times the mass of our sun, sometimes 10, maybe a bit more. We can spot them when they steal matter from a nearby star, heating up the stolen gas until it glows with X-rays. That glow is like their signature, like a cosmic "I was here." And then, on the opposite end, there are the supermassive black holes. These are absolute beasts, millions, even billions of times more massive than our sun. They sit right in the heart of galaxies, like bosses running the whole show. They bend light, twist time, and pull on everything around them, Stars, planets, clouds of gas, even entire star clusters. And we can detect those because they're so loud. Not sound loud, but energy loud. They make galaxies light up like neon signs. But in the middle, for a long time, there was nothing. Which makes no sense, right? You'd think there would be something in between. Something connecting the small ones to the big ones. Something halfway. That's where intermediate black holes come in. They're the middle children of the black hole family. And just like real middle children, they often get overlooked. Not because they're unimportant, but because they're just incredibly hard to find. They're too small to make the kind of noise supermassive black holes do, and they're too big to be created by one dying star. They don't glow like the small ones, and they don't scream like the big ones. They just wait, in silence. And that silence, it's what makes them so terrifying. You could have one right now, drifting through a star cluster or hiding inside a quiet galaxy, and you'd never know it was there. One theory is that intermediate black holes are formed when smaller black holes merge over time. Picture it. Two black holes collide and combine. Then, those merged ones keep colliding with others. Over millions, maybe billions of years, you could end up with something too massive to be stellar, but still not massive enough to be supermassive. A black hole that's stuck in the middle. Not quite a newborn, not quite a giant. Just a ghost, growing in the shadows. But even if that's true, that still doesn't explain why they're so rare to spot. If stellar black holes can form from dying stars all over the galaxy, and if supermassive ones are sitting at the core of almost every major galaxy, then intermediate black holes should be scattered everywhere in between, right? Well, that's the thing. They're probably not rare. We just can't see them. Most black holes, as we know, don't emit light. The only time they give away their location is when they interact with other matters. If there's gas falling into them, they heat it up, and it glows. If there's a star getting torn apart, it lights up like a flare. That glow travels through space and hits our telescopes, telling us there's something here. But intermediate black holes, they're often too quiet. They don't always have a lot of gas around them. They might not be near anything big enough to eat, so they just sit there. No accretion disk, no X-ray glow, no fireworks, just darkness. And the deeper into space you look, the harder it gets to spot that kind of silence. But once in a while, we get lucky. In a galaxy called M82, about 12 million light-years from Earth, something caught our eye, something strange. It was blasting out X-rays, way more than any stellar black hole should be able to produce. It wasn't a star, and it wasn't a supermassive black hole. It was something else. We named it M82X-1. It could be the first real evidence of an intermediate black hole. Its X-ray output is too high for a stellar black hole, and it's not in the center of the galaxy, where supermassive ones usually live. It's floating out there on its own, glowing just enough to be noticed, but only if you're paying attention. If M82X-1 really is an intermediate black hole, it's probably about 400 times the mass of our Sun. That puts it right in the missing link zone, too big to be made by one star, too small to be running a galaxy. It's exactly the kind of object we've been looking for, and if it's real, then it means something huge. It means black holes really do grow step by step. It means those tiny stellar black holes could be the building blocks of the universe's most terrifying giants. It means that somewhere out there, probably in dozens or hundreds or thousands of galaxies, black holes are still climbing the ladder, still merging, still evolving. And that means our supermassive black hole, Sagittarius A star, might not have started supermassive. It might have been small, then it ate, then it merged, and over billions of years, it became the monster we see now. That idea flips our understanding of the universe on its head. It means galaxies don't just form around black holes. Black holes might actually be the seeds that grow into galaxies. But it gets even weirder. Some researchers believe that intermediate black holes, might be the key to understanding how galaxies grow and die. Think about it. If you've got a few hundred black holes scattered around a galaxy, and they're slowly merging over time, then the center of that galaxy becomes a black hole nursery. All those little collisions send out gravitational waves, ripples in space itself. And those waves, we've already started to detect them. In 2019, we picked up a gravitational wave signal called GW190521. What made it special is that it came from the merger of two black holes, one about 85 solar masses and the other about 66. The result? A single black hole that was 142 times the mass of the Sun. That's right in the intermediate zone. This was the first time we'd seen a black hole of that size form in real time. It wasn't just a theory anymore. It happened. And that changed everything. The universe suddenly seemed a little more crowded, a little more unpredictable. Because if black holes can merge into intermediate ones like that, then it's happening everywhere. Not just in some distant galaxy, but maybe right here, in our own Milky Way. Maybe there's a quiet cluster of stars where something is stirring, a black hole no one's noticed yet, waiting for its next meal, waiting to grow, waiting to become something even worse. And the scariest part? There's no limit. Once an intermediate black hole gets big enough, it becomes unstable. It pulls more matter. It grows faster. Its gravity gets stronger. It starts to curve space around it more violently. And eventually, it tips into the supermassive category. At that point, it's not just scary, it's cosmic. It begins influencing entire star systems. It heats up galaxies. It creates radiation jets that shoot across millions of light years. And it doesn't stop there. Because remember, black holes don't die. They might evaporate over trillions of years through Hawking radiation, but that's so slow it barely matters. In human or even galactic timescales, a black hole is immortal. Once it's made, it stays. Forever. That's what makes intermediate black holes so terrifying. They're not just big. They're not just hard to find. They're growing. Right now. Out there. And by the time we spot one, it might already be too late. So yeah. Intermediate black holes might be the missing monsters. But if we're being honest, maybe they were never missing at all. Maybe they were just hiding. Sagittarius A, the one in our backyard. There's a monster sitting in the middle of our galaxy. It doesn't growl, it doesn't roar, it doesn't even move much. But it's there, watching, waiting. Right now, it's quiet. But make no mistake, it's a black hole. And not just any black hole. This one is massive, powerful, and dangerously close compared to the others we've found. Its name is Sagittarius A star, and it's at the very heart of the Milky Way, the same galaxy we live in. If our galaxy was a city, this black hole would be the giant tower in the center, pulling the skyline inward, warping the streets, and silently holding everything together. Now, here's the part that should get your attention. It's over 4 million times the mass of our sun. Think about that. Our sun is already huge. It's over 100 times the width of Earth and more than 1 million times heavier. Yet this black hole just casually outweighs it by a factor of 4 million. That kind of mass doesn't just sit around doing nothing. Even when it's not eating, it's pulling, warping, bending everything around it. Sagittarius A star has been there for billions of years. That's longer than Earth has existed, longer than our sun has been shining. While we've only just figured out it exists, it's been quietly shaping the galaxy this whole time. Every single star in the Milky Way, including our sun, is slowly orbiting around it. We are literally spinning around a cosmic drain. And yeah, that's as terrifying as it sounds. Here's what makes this thing so eerie. It's calm, way too calm. Most black holes we've studied, especially supermassive ones, tend to make a lot of noise. Not sound, of course, but activity. They devour gas clouds, tear stars to pieces, and blast out insane amounts of radiation. They glow in X-rays. They shoot out beams of energy. They make themselves known. But Sagittarius A star, it's been unusually quiet. It's like a sleeping lion in the middle of a crowded room. You know it's there. You can feel the tension. But it hasn't made a move. Yet. Scientists think it's what we call a dormant black hole. That doesn't mean it's dead. It just means it's not feeding right now. It's not pulling in huge clouds of gas or chunks of stars, so it's not radiating that much energy. But that doesn't mean it's harmless. It means it's biding its time. And we have reason to believe it wasn't always like this. When scientists point their telescopes toward the center of the galaxy, they don't just look at light, they look at movement. The stars closest to the center move in bizarre, super-fast orbits, slingshotting around something invisible, something small, compact, but unimaginably heavy. That's how we know Sagittarius A star is there. But it's more than that. We've seen signs, trails of gas, streams of material, that suggest something big happened there not too long ago. Big enough to leave scars in space. The kind of event only a ravenous black hole could create. Some scientists believe that millions of years ago, Sagittarius A star was active, very active. Maybe it swallowed a gas cloud the size of a planet. Maybe it shredded a few stars. Whatever it did, it left behind signs of violence, blasts of energy, heated dust, and X-ray echoes that bounce around like whispers from the past. But now it's sleeping again. Quiet. Still. Too still. Here's the part that keeps astronomers up at night. Black holes don't stay dormant forever. All it takes is one unlucky star to wander too close. One dense gas cloud to drift into its gravitational grip. One massive object to fall in. And when that happens, Sagittarius A star will wake up. And it won't wake up slowly. It'll snap into action like a wild animal that just smelled blood. It'll start feeding again, violently. It will drag in everything it can. Matter will spiral inward, heat up to millions of degrees, and form an accretion disk. That disk will glow brighter than anything else in the sky. It could outshine every star in our galaxy combined. It would blast out X-rays and gamma rays, jet streams of charged particles, and shock waves that ripple across the galactic core. And we'd see it. Even from Earth, 26,000 light-years away, the light show would be unmistakable. It would appear in the sky as a brilliant flare, a beacon of chaos where there used to be darkness. Telescopes would light up with alerts. The data would pour in, and everyone, from scientists to school kids, would be talking about the monster in the middle of our galaxy waking up. But this isn't just science fiction. This is something that's already starting to happen. In 2019, astronomers observed something weird. Sagittarius A star flared up. Just for a moment, it got 75 times brighter than normal in the infrared spectrum. Then, just as quickly, it faded back down. We don't know what caused it. It might have just eaten something small, a wayward asteroid, a clump of gas, a warning shot. Whatever it was a reminder. This thing isn't dead. It's alive, and it's watching. Even more alarming is the fact that a massive gas cloud, called G2, passed dangerously close to Sagittarius A star not long ago. At first, scientists thought it would get torn apart and feed the black hole, but it survived. Sort of. Some of its outer material may have been stripped away. Some of it might still be on its way inward, slowly spiraling toward the event horizon. If that happens, the flare won't be small. It could be huge, and we wouldn't have time to stop it. Not that we could. It's not a threat in the traditional sense. It's not like it's coming for us. It's too far away to physically harm us. But the radiation it releases could have effects we haven't even begun to understand. It could scramble satellites, interfere with signals, and more than anything else, it would be a giant blinking sign from the center of the galaxy, reminding us that we're tiny, fragile things, orbiting a silent, invisible beast. It gets worse. Some theories suggest that black holes like Sagittarius A star don't just grow by eating stars and gas. They might merge with other black holes. If the Milky Way ever collided with another galaxy, like the nearby Andromeda Galaxy, which we are on a collision course with, the two central black holes would eventually spiral into each other. And when that happens, it would be one of the most energetic events in the universe. Two supermassive black holes slamming into each other, merging, collapsing into something even bigger. It would send gravitational waves across the cosmos, ripples in the fabric of space itself. It would shake the galactic core, and it would change everything. Sagittarius A star isn't just a massive object with a cool name. It's a mystery, a danger, a question that hasn't been answered yet. It's a reminder that the universe doesn't owe us anything, not safety, peace, or even understanding. We like to think of space as empty, cold, predictable, but right in the middle of everything we know, there's a hole in space, a place where time slows down, where matter breaks apart, where light goes to die, and we're orbiting it. That's the part that sticks with you. We're not just in the same galaxy as Sagittarius A star, we're its neighbor. Our entire solar system is part of its web. We're tied to it, whether we like it or not. And while it might not swallow us tomorrow, or even in a billion years, its presence shapes our reality every single day. So next time you look up at the night sky and see all those stars shining, just remember, at the center of it all is a black hole. Quiet, dark, and very much alive. Ton 618, the giant we shouldn't have found. Ready for something absolutely insane? There's a black hole so big, so unbelievably massive, that it breaks your brain just trying to picture it. It's called TON 618, and if you've never heard of it before, don't worry. Most people haven't. It's not exactly trending in everyday conversations, but it probably should be, because this thing isn't just huge. It's terrifying in a way that's hard to put into words. Let's just start with the basics. TON 618 is an ultra-massive black hole located about 10 billion light-years away from Earth. That already sounds like science fiction, right? 10 billion light-years. That means the light we're seeing from it, the photons hitting our telescopes, left that black hole before Earth even existed. That's not just old. That's older than dinosaurs, older than the sun. We're literally looking back in time. And here's the part that melts people's brains. TON 618 is estimated to have a mass of over 40 billion times that of our sun. Let that sink in for a second. 40 billion suns. If that number doesn't feel real, it's because it isn't. Our brains just aren't wired to understand something that massive. Now imagine our solar system. Everything from Mercury to Neptune, including the sun, all the planets, moons, and even the Oort cloud. All of that could comfortably fit inside TON 618's event horizon. And not just fit, there'd be room left over. This thing is so massive that light itself can't escape its grip for hundreds of billions of kilometers in every direction. That's how powerful its gravity is. But here's what really keeps scientists up at night. We shouldn't be able to see it. Think about that. The universe is around 13.8 billion years old. The light from TON 618 has been traveling toward us for about 10 billion years. That means TON 618 existed when the universe was barely 3.8 billion years old. In cosmic terms, that's basically the toddler years. Galaxies were just forming, stars were just starting to settle down, and yet somehow this monster black hole already existed. That doesn't make sense. According to our best theories, black holes grow over time. They start small, from dying stars or maybe from collapsing clouds of gas, and slowly, over billions of years, they eat their surroundings. Dust, gas, stars, other black holes. They feed, they grow. But even with a steady diet, the math doesn't add up. There just hasn't been enough time for a black hole to reach 40 billion solar masses that early in the universe's history. So how did it get so big, so fast? We don't know. Seriously, scientists don't have a clear answer, and that's one of the reasons TON 618 is so terrifying. It's like a cheat code in the fabric of the universe, something that breaks the rules we thought were unbreakable. It forces us to ask if there's something missing in our understanding of physics, gravity, or even how black holes form. There are theories, of course. There always are. Some scientists think TON 618 might have formed from the direct collapse of a massive gas cloud, skipping the whole star dies then becomes a black hole thing. That would have given it a head start. Others think maybe it's been through multiple black hole mergers, over and over again, snowballing into a cosmic heavyweight. But even those ideas struggle to explain how it got that big in such a short time. And then there's the really unsettling idea. What if TON 618 isn't rare? Let's say for a second that TON 618 isn't a fluke. What if there are dozens, maybe hundreds of black holes like it scattered across the universe? Ones we just haven't seen yet. Ones hiding in the darkest, most distant corners of space. Ones so far away, their light hasn't even reached us. That's not just terrifying, that's existential. Because if they're out there, what does that mean for the structure of the universe? What does that mean for galaxies? For life? It gets even creepier when you think about the effects of something that massive. TON 618 isn't just a big lump of mass. It's an active black hole, meaning it's currently feeding. It's sucking in matter from the surrounding galaxy and creating an accretion disk, a swirling, glowing ring of superheated gas and dust that spins around it at nearly the speed of light. That disk burns so brightly that TON 618 outshines entire galaxies. That's how we spotted it in the first place. Not from the black hole itself, because remember, light can't escape a black hole, but from the blazing light of the material being pulled into it. In fact, TON 618 is technically a quasar, one of the brightest, most energetic objects in the universe. Quasars are powered by supermassive black holes, but TON 618 puts most of them to shame. This thing is like a lighthouse in the void, except instead of guiding ships, it's screaming across the cosmos. I'm huge, I'm old, and I don't make sense. And that kind of energy comes at a cost. The radiation blasting out from the accretion disk is so intense that it can push matter away, stopping stars from forming nearby. TON 618 doesn't just exist inside its galaxy. It controls it. It shapes the environment. It dominates everything in its gravitational reach. Now here's a fun little nightmare thought. What if our galaxy had something like TON 618 at its center? Right now, the Milky Way is relatively chill. Our central black hole, Sagittarius A, is about 4 million times the mass of the Sun. That sounds huge, and it is, but compared to TON 618, it's nothing. It's a baby. It's a sandbox black hole. TON 618 is a skyscraper. If something like TON 618 were at the center of the Milky Way, the entire galaxy would be different. The stars would orbit differently. The spiral arms might not exist at all, and depending on how active it was, it could flood huge regions of space with lethal radiation. Life might not have evolved here at all. So yeah, we're kind of lucky. But that brings us back to the weirdest part of all. Why TON 618? Why this black hole? Why is this the one we found? Is it just a freak of nature? Or is it a sign of something bigger, something we're just starting to uncover? Because here's the thing, astronomy is basically time travel. Every time we look deeper into space, we're looking further back in time. And TON 618 is one of the oldest and brightest things we can see. It's a snapshot of a moment in the early universe, a clue, a warning, maybe even a glitch in the cosmic code. We've built the best telescopes humanity has ever made, and TON 618 is still just a blurry dot. We don't even fully understand its surroundings. We can't see what it's orbiting. We can't measure its spin. We can't detect what it's done in the last 10 billion years. We're watching the ghost of what it used to be, and that's all we've got. And yet, even that ghost is enough to freak us out. This isn't just a black hole. It's a cosmic monster, a question mark floating in the abyss, a reminder that the universe is still full of things we can't explain, and might never understand. TON 618 breaks every rule we thought black holes followed. It shows up too early, grows too fast, shines too bright, and weighs too much. It challenges everything. And the worst part? It's probably not alone. So yeah, if you ever feel like you've got life figured out, just remember there's a black hole out there that could swallow a galaxy. And we don't even know how it got here. That's TON 618. And it's the kind of terrifying that doesn't scream. It just stares back at you across the void and dares you to look closer. Primordial black holes. Ancient and invisible. There's a type of black hole out there that could be older than the stars themselves. Not just older than the sun or the Milky Way, older than anything we know. These aren't formed from dead stars or the collapse of massive suns. They're far stranger than that. In fact, if they exist at all, they might be the first things the universe ever made. They're called primordial black holes. And the terrifying thing is, we still don't know if they're real. So what makes primordial black holes so different from the ones we've already talked about? Well, most black holes we know of are born in violent ways. A huge star runs out of fuel, its core collapses, and it explodes in a supernova. What's left behind is a super-dense remnant, a stellar black hole. That's the basic story we've been able to observe again and again. But primordial black holes don't follow that story. They weren't made from stars. They weren't made from anything you'd recognize. Instead, these things, if they exist, were forged in the first fraction of a second after the Big Bang. Back then, the universe wasn't a calm, empty space. It was pure chaos. Everything was hot, dense, and unstable. Matter didn't exist yet. There were no stars, no galaxies, not even atoms. Just energy and wild fluctuations in density across an expanding universe. In that early mess, there were regions where the energy density wasn't uniform. Some spots were denser than others, and in those insanely compact regions, gravity could have taken over, crushing pockets of energy into singularities, black holes. These wouldn't be born from death. They'd be born from imbalance. No stars, no explosions. Just raw gravitational collapse from the fabric of the universe itself. That's what makes primordial black holes so eerie. They weren't created by destruction. They were created by creation. Some of them might be incredibly tiny, like atom-sized. Others might be as large as a mountain. But no matter their size, one thing would make them all dangerous. We wouldn't see them coming. Unlike regular black holes, primordial black holes might not be part of a galaxy. They wouldn't have formed inside stars or from clusters. They might just be drifting through the universe, alone, cold, and completely undetectable. No light, no X-rays, no clues. Unless one of them happens to pass in front of a star and bend its light. Or worse, gets too close to something and starts tearing it apart. We wouldn't even know it was there. Now here's where things get even weirder. One of the biggest mysteries in modern physics is dark matter. That's the invisible stuff that makes up most of the mass in the universe. We can't see it, we can't touch it, but we know it's there, because its gravity holds galaxies together. Without dark matter, the outer stars and galaxies would spin off into space. But they don't. Something is keeping them locked in place, and we've been trying to figure out what that something is for decades. Here's the twist. Some scientists believe primordial black holes could be that something, that they are dark matter. Think about that for a second. The universe might be full of tiny ancient black holes, everywhere, scattered across space, passing through galaxies, clustering together, maybe even zooming past Earth from time to time, completely undetected. And that's where the real fear kicks in. If they are dark matter, we're surrounded by them, constantly. But because they don't emit any light, and they're too small to detect unless they interact with something, we're practically blind to them. They could be floating near stars, hovering in the gaps between planets, or even drifting through our own solar system without us ever knowing. The idea isn't just theoretical anymore. In recent years, researchers have been trying to spot signs of these ghostly black holes using something called gravitational microlensing. That's when a black hole passes in front of a distant star, bending its light like a magnifying glass. It's rare, but it's one of the only ways we might detect a small, isolated black hole, and there have been some signals that might match the signature of a primordial black hole. Nothing confirmed, but enough to make people start asking serious questions. What if these things are hiding in the data? What if they're responsible for some of the weird stuff we've seen in deep space but can't explain? What if our entire understanding of the cosmos is missing this crucial piece, because the pieces are invisible? Even worse, what if one of them is headed our way? If a small primordial black hole entered our solar system, it wouldn't announce itself. There'd be no flash, no warning, but its gravity would start to mess with things. It could shift the orbits of planets. It could pull on comets or asteroids. In the worst-case scenario, it could fall into the sun or straight into Earth. If that sounds dramatic, it is. But it's not impossible. Even a black hole the size of a marble could contain the mass of an asteroid. One that small could sink through the Earth's crust without stopping, eating its way through the planet's core before we even realized what happened. The Earth wouldn't explode. It would just quietly collapse from the inside out. Slowly, silently, gone. That's the horror of primordial black holes. They're not loud. They don't shine. They don't warn you. They just exist. And they've been doing so for billions of years. Older than the first stars. Older than the first atoms. Relics of a time before time. And they might not just be floating around aimlessly. Some theories suggest these black holes could have played a role in shaping the very structure of the universe. In those early moments after the Big Bang, the universe needed something to pull matter together, something to kickstart galaxy formation. Maybe primordial black holes were those seeds. Maybe they gathered gas and dust around them, becoming the anchor points for the first galaxies to grow. If that's true, then every galaxy in the universe might have started from one of these ancient objects, including ours. Meaning the Milky Way itself could have been born from a black hole smaller than a pebble, one that's still out there, quietly existing at the center of everything. And here's another twist that messes with your brain. If primordial black holes really are dark matter and they helped form galaxies, then black holes might not be the end of the universe, like we used to think. They might have been the beginning. That flips everything upside down. Normally, black holes represent death, finality, the collapse of stars, the erasure of information. But primordial black holes suggest the opposite. They might be the first architects of the cosmos, the builders, not the destroyers. But that's assuming they exist, and that's the hardest part about this whole thing. We don't know. Despite all our telescopes, satellites, detectors, and models, we can't say for sure if primordial black holes are real. Every time we think we might be seeing one, there's always another explanation. Every time we run the numbers, the models get complicated. But they could be real, and if they are, we'll need to rewrite entire textbooks. Everything we thought we knew about gravity, matter, space, and time would have to change. Because then, black holes wouldn't just be out there. They'd be everywhere, hiding in the walls of reality, shaping the universe from the shadows. And maybe that's why we haven't found them yet, because they're not meant to be found. They've been here since the beginning, and they'll be here long after the last star fades. Silent, timeless, watching. That's the thing with black holes. The more we learn about them, the scarier they get. But these ones, the primordial kind, they're the worst of all, because they're not just terrifying. They're ancient, they're invisible, and they could be all around us, right now. The recoiling black hole, shotgun through the cosmos. Sometimes the scariest things in the universe aren't the ones that stay put. It's the ones that move, quietly, without warning, without light, without rules. And that's exactly what happens when a black hole gets kicked out of its home like a cosmic bullet. You've probably heard of black holes sitting at the center of galaxies, pulling in matter, shaping stars, and bending time. But not all black holes like to stay in one place. Some of them run. They're called recoiling black holes, and they're some of the most terrifying objects we've ever discovered, or imagined. Not because of what we see, but because of what we don't. Because when a black hole gets kicked, it turns into a rogue, a drifter, a silent wrecking ball flying through space at unimaginable speeds. And if it's headed our way, we'll never know until it's too late. To understand how this happens, we need to go back to the beginning of this nightmare scenario. Picture two black holes caught in each other's gravity. They're spiraling closer, moving faster and faster, like dancers in a deadly waltz. As they get closer, the space around them stretches and bends, and the energy they release ripples out in waves, gravitational waves. These are distortions in space-time itself, like invisible shock waves that race through the universe. Now here's the thing. These waves don't always come out evenly. If the two black holes aren't perfectly matched, maybe one is spinning faster, or one is way bigger than the other, the energy they release is lopsided. The gravitational waves shoot out more strongly in one direction than the other, and just like when you push off a wall and launch yourself backward, the merged black hole feels the recoil. It gets blasted in the opposite direction, flung into space like a cosmic shotgun shell. And the speed? We're not talking about a gentle drift. Some of these black holes have been predicted to move at thousands, even tens of thousands of kilometers per second, fast enough to escape their home galaxy, fast enough to disappear into intergalactic space, fast enough to cross millions of miles in the time it takes you to finish this video. This is where things get chilling, because once that black hole is kicked out, it doesn't stop. There's no friction in space, no air to slow it down. It just keeps going, forever, alone. And what's worse, it carries all of its terrifying physics with it. This isn't a harmless object. This is a point in space where gravity is so intense, not even light can escape. If a recoiling black hole were to pass near a star, it could tear it apart. If it came close to a solar system, it could slingshot planets out of orbit, crash into stars, or consume entire worlds. And if it passed through a galaxy unnoticed, it could leave trails of destruction in its wake, like a silent assassin. Now imagine one of these things heading straight toward us. There'd be no warning, no glow, no flicker of light. Unless it's actively feeding on something, a black hole doesn't emit anything we can detect. It's invisible, totally black. The only way we'd notice it is if it started messing with nearby stars, or if it suddenly appeared close enough for its gravity to start pulling on us. And by then, it's already over. Some scientists think there could be thousands of recoiling black holes out there, maybe more, and they wouldn't be in places we expect. We tend to look for black holes in the center of galaxies, surrounded by stars, gas, and dust. But a recoiling black hole, it's out in the middle of nowhere, a million light years from anything. And that's what makes them so hard to detect. They don't glow, they don't scream, they don't even whisper. They just move. And here's the twist. We've seen hints that these things are real. In a few galaxies, astronomers have found signs that something is missing. In one case, they found a quasar, an insanely bright object powered by a supermassive black hole, but it wasn't at the galaxy's center. It was off to the side, like it had been dragged or flung out of place. The light showed trails, like the black hole had pulled stars and gas along with it. It looked like a black hole on the run, a recoiling giant caught in the act. One galaxy showed a displaced black hole moving at 2,000 kilometers per second. That's fast enough to escape its entire galaxy. Think about that. This black hole was once the anchor of its home, the heart, and now it's been kicked out, turned into a lone wanderer with nowhere to go and nothing to stop it. A monster, unchained. The physics behind this is real. We've detected gravitational waves from black hole mergers. We know they happen, and we know those waves can carry away huge amounts of energy. The more unbalanced the black holes are, the more intense the recoil. Some scientists even think that the universe could be full of these runaway black holes, that every time galaxies merge, there's a chance one of these things gets launched into space. Now, picture the early universe. Chaotic, crowded. Galaxies crash into each other like bumper cars. Black holes merge over and over again. With every merger, more recoil. More black holes shot into space. Over billions of years, they drift far from where they started. Alone. Dark. Deadly. And it gets weirder. Because a recoiling black hole doesn't always leave quietly. Sometimes it takes things with it. Gas, stars, even entire clusters. It can rip through its galaxy, dragging material in a glowing tail behind it. And if it's moving fast enough, it can leave behind a trail of heat and radiation, a kind of cosmic scar marking where it passed. Some recoiling black holes might have active accretion disks, rings of gas and dust spiraling into them, lighting up in X-rays and radio waves. Others might be totally invisible, drifting through the void with nothing around them. We might detect them someday, or we might never see them at all. And the horror of it all? You could be orbiting a star right now. Everything seems fine, planets spinning, life thriving. But far beyond your system, a silent traveler is approaching. A runaway black hole kicked out billions of years ago, moving at thousands of kilometers per second. No light, no heat, just gravity. And one day, it arrives. First, the outer planets start to wobble. Their orbits shift. Then gas clouds get pulled out of shape. The sun starts to dim. Strange tidal forces ripple across space. And then, like a thief in the night, the black hole arrives, pulling, shredding, devouring. There's no time to react, no time to escape, because by the time you realize it's there, it already owns you. It's not science fiction, it's real physics, real possibilities, and we're just starting to understand how often this might happen. Some scientists believe that these events, recoiling black holes, could explain other cosmic mysteries. Why some galaxies appear to be missing their central black holes? Why do some quasars seem out of place? Why do we see high-speed jets in unexpected directions? It all points to a universe that's more chaotic, more violent, and more unpredictable than we ever imagined. And that's the scariest part of all, because these black holes don't just defy gravity, they defy control. You can't predict where they'll go. You can't stop them. They don't orbit. They don't obey. They run wild, forever. They're not just black holes anymore. They're ghosts, cosmic ghosts with the mass of billions of suns, drifting through the dark. And one day, you might look up and realize that something is pulling on the stars, that the night sky is shifting, that gravity feels different, and by then, it's too late. You'll never hear it. You'll never see it. Just silence and then nothing. Time warping, black holes. Where time stops. Here's where black holes go from terrifying to completely mind-breaking, because they don't just pull in stars, planets, or light. They pull in time itself. That sounds like science fiction, but it's real. Time, something we all take for granted, is not constant. It can stretch, it can slow, it can twist. And nowhere in the universe does that happen more dramatically than near a black hole. Now we all live in what feels like a predictable rhythm. A minute is a minute, an hour is an hour. You wake up, the clock moves forward, and the world ticks along at a steady pace. But near a black hole, that rhythm goes haywire. It's like pressing slow motion on reality itself. This isn't just a theory. It's one of the strangest things Einstein figured out with his theory of relativity. And black holes take that theory and crank it to the extreme. The closer you get to one, the more warped time becomes. If you're far away from the black hole, time ticks normally. Nothing weird. But as you inch closer to the event horizon, the point of no return, something wild starts to happen. Let's say you're in a spaceship, hovering just outside the event horizon of a supermassive black hole. You're stable, just floating there. From your point of view, inside the ship, everything feels fine. Your heart beats normally. You're breathing at a normal pace. You're looking at the clock. It's ticking like usual. But if someone were watching you from a distance, from far away, like from Earth, they'd see something totally different. To them, you'd start moving slower, not because you're physically slowing down, but because time itself is stretching around you. Every second for you feels like a second. But for them, that same second might stretch into a minute, then a day, then a year. The deeper you go into the black hole's gravity, the more extreme this gets, until eventually, you'd appear almost frozen in time. From the outside, it would look like you're stuck in place, like a paused video, barely moving, suspended in a moment that never ends. But inside your ship, you'd still be thinking, breathing, living, completely unaware that from another point of view, the universe around you is speeding ahead, rushing into the future like a time lapse on steroids. This effect has a name: gravitational time dilation. It's not just a weird trick of perspective, it's real. Time genuinely moves slower for you, the deeper you are in a strong gravitational field. We've even measured this on Earth, on a much smaller scale. Clocks placed at sea level tick slightly slower than those at the top of a mountain. The difference is tiny, but it's there. And around a black hole, it's not tiny anymore. It's dramatic. So what happens if you actually try to leave? Let's imagine you spend just 1 hour hovering near the edge of a black hole. Then you turn around and head home. When you get back, Earth has aged, but not by an hour, maybe by 100 years, or 500, or 10,000. Everyone you know is gone. Entire civilizations have risen and fallen. All of human history might have played out in the time it took you to listen to a playlist and sip some tea. And that's not science fiction. That's physics. You wouldn't have felt anything strange. You weren't in a coma. You weren't frozen. You were alive and awake, watching your clock tick along like normal. But from the universe's perspective, you just time traveled. And here's where it gets even weirder. Let's say you don't turn around. Let's say you drift a little too far, past the edge, past the event horizon. Now you've crossed a line where nothing, not even light, can escape. You're inside. Now from your point of view, again, nothing dramatic happens. There's no sudden flash, no explosion, no feeling of crossing a boundary. You just keep moving forward, deeper into the black hole's gravity. But from the outside, you vanished. You fade, you stretch, and then you're gone. The event horizon isn't just a physical barrier. It's a wall between what we know and what we don't, between what we can observe and what we never will. Everything beyond it is hidden forever, trapped in a place where time moves in a direction we can't follow. From Earth, you'd look like you froze just outside the edge, like you're stuck, reaching towards something you'll never touch. But that's not what you experience. You fall. Time keeps ticking. But space and time are now so warped, so twisted, that forward no longer means what it used to. Your sense of direction breaks down. You can't escape, not because you're being pulled, but because the future itself now points inward. There's no way out, not even in theory. And at the very center, something even stranger waits. It's called the singularity. That's where all the mass of the black hole is thought to exist, but not spread out. It's crushed into an infinitely tiny point, a place of infinite density. We have no clue what happens there. None of our equations work. Physics just breaks. If you reach that point, you'd be crushed down into nothing. All the matter that made you, you as a person, you as a machine, you as a body, would be compressed into a single point, smaller than an atom. But what does that mean, really? We don't know. Nobody does. And here's a thought to lose sleep over. If time slows down, the closer you get to a black hole, and stops entirely at the event horizon, what happens at the singularity? Does time even exist there? Could it be that everything that ever fell into the black hole, every star, every planet, every signal, every person, is still there, frozen in some warped slice of time we can't comprehend? Or is it all gone? Now some theories suggest something wild. What if the singularity isn't the end, but a doorway? Some physicists believe that inside every black hole might be a tunnel, a wormhole, leading somewhere else, another part of the universe, another time, maybe even another universe entirely. It's purely theoretical, but if true, that would mean falling into a black hole doesn't mean you're destroyed. It means you're transferred. To where? To when? Nobody knows. Others think that black holes might be the seeds of entirely new universes, that when enough matter gets crushed into a singularity, it doesn't collapse forever. It bounces, it explodes, it expands. Sound familiar? That's basically what the Big Bang was, a point of infinite density exploding into space and time. What if every black hole is the beginning of a new universe? That means somewhere out there, inside these terrifying monsters, whole galaxies might be being born, suns igniting, planets forming, life maybe even beginning. And from our point of view, we'd never know, because we're stuck on the outside, watching from a distance, helpless to follow. Black holes turn everything inside out. Light can't escape them. Matter is crushed in them. And time bends, stretches, slows, stops. They don't just bend space. They twist our understanding of what it means to exist, to be here, now. And that's why they're terrifying. Not just because they can destroy you, but because they show you how little you understand the universe. They make time, the one thing we thought we could trust, fall apart. They erase the difference between past, present, and future. They remind us that there are places out there where the laws of nature simply don't work. So next time you think of a black hole as just a dark spot in space, remember this. It's not just a hole. It's a place where reality itself stops making sense. And if you ever got too close, you wouldn't just be lost in space. You'd be lost in time. Forever. Spaghettification, the most horrifying way to die. There are some fates in the universe that are so horrible, so impossible to imagine, that they barely seem real. But then, you learn that they're not only real, they're possible. And sometimes, in the case of black holes, they're almost guaranteed. One such fate is spaghettification. It's a concept that's chilling in its simplicity and horrifying in its execution. And it's a real thing that happens if you get too close to a black hole. So, what does it mean to be spaghettified? To understand that, you need to picture yourself drifting toward a black hole, one of those invisible monsters in space, with a gravitational pull so intense that not even light can escape it. But unlike movies where you see spaceships getting sucked in, the truth of what happens next is far worse. Imagine this. You're falling toward a black hole. It's not like a regular fall. This is no ordinary drop. Black holes are objects so dense and massive that they warp the very fabric of space and time around them. When you get close to one, gravity begins to act in ways that are almost incomprehensible. The first thing you'll notice is that gravity is pulling at you from all directions. But here's the catch. Gravity is not the same everywhere near a black hole. As you fall closer, the difference between the force on your feet and the force on your head becomes more and more extreme. If you were standing upright, your feet would be experiencing far stronger gravity than your head. Imagine being pulled toward a giant whirlpool in space, but instead of just feeling a tug from all sides, you feel the strength of the pull intensifying as you approach the event horizon, the point of no return. The difference in gravitational pull between the top and bottom of your body becomes so extreme that the very structure of your body starts to stretch. At first, it might feel like a weird sensation, like a strong pressure, but then it gets worse. Your body begins to stretch. Your feet are pulled harder. Your head experiences much less force, and this difference grows larger the closer you get. The result? You are stretched out like a string of spaghetti, hence the name spaghettification. This process isn't just uncomfortable, it's catastrophic. It's like the gravitational force of the black hole becomes a giant cosmic hand that's slowly and painfully tearing you apart. You would feel the difference in pressure as your body is ripped into a long, thin shape, pulling you further and further into that singularity at the center of the black hole. But the horrors don't stop there. As your body gets stretched, the very molecular structure of your cells starts to break down. You don't just get stretched physically, your atoms and molecules begin to separate. The same forces that pull you apart are also disrupting the bonds that hold you together. Imagine feeling your skin, muscles, and bones begin to tear apart, not in a violent crash, but in a slow, agonizing stretch that seems endless. As you get closer to the event horizon, this stretching effect becomes so extreme that it happens to you on the atomic level. Your body is essentially being unwound, atom by atom. It's a fate worse than being crushed. It's a slow unraveling of your very existence. The stars that you could have once seen as bright lights will now be out of your sight as the light itself gets bent and warped by the gravitational field of the black hole. The last thing you would see is the universe stretching into infinity. But here's the kicker. You can't escape. As you get closer to the event horizon, the fabric of time itself begins to warp. From your perspective, everything around you starts to slow down. But from the outside observer, you appear to be moving in slow motion, as if time is stretching out for you as well. The farther you get, the more time seems to stretch and drag. Your experience of time will start to diverge from that of everyone else. In the final moments, you will be frozen in time, as seen by anyone watching from the outside. It's as if the moment you cross that line is the moment you're suspended in a state of slow motion, endlessly stretching toward the black hole. The fact that this happens slowly doesn't make it less terrifying. It makes it worse. You would know what's happening to you every second, but be powerless to stop it. It's like being trapped in an eternal state of agony and stretch. Now, let's talk about what would actually be happening to you in terms of physics. The whole process relies on tidal forces, which are the differences in gravitational pull across an object. For an object as massive and dense as a black hole, these tidal forces are immense. A black hole doesn't just pull things into it, it stretches and compresses them as it pulls. This is what happens to the stars that get too close. They don't get sucked straight in. They get torn apart by the tidal forces and drawn in from every direction. So if you're falling feet first, as your body gets stretched, your spine would get pulled apart first. The force would be so powerful that it would rip you from your feet, and your upper body, from your head down, would be stretched out into a long, thin line. It's so extreme that the human body can't even begin to withstand it. It's like a violent but slow disintegration. Imagine for a moment what this might feel like. It's not like a fast impact where you barely have time to register pain. It's a slow, prolonged process. The agony would be unthinkable. As your body is pulled into a thin, almost microscopic line, each cell, each part of your body, would be under increasing stress. You would be aware of every minute detail, from your skin stretching and cracking, to your bones slowly being snapped under the pressure. As your cells get stretched, so does your nervous system, which means you would feel the entire process. The last thing you would feel is the end of your existence, when your atoms and molecules become so stretched that there is nothing left to keep you whole. And here's the thing, no matter how powerful you are, whether you're a human, a planet, or even a star, you can't escape this fate. The black hole doesn't care what you are. It doesn't matter if you're made of atoms, like us, or if you're made of gas and light, like stars. The black hole just keeps pulling. It doesn't stop for anything. The reason it doesn't stop is simple. It can't. A black hole is like the ultimate predator, devouring anything that gets too close. It pulls everything into its core without hesitation, no matter the consequences. And once you cross that event horizon, your fate is sealed. There is no way back. Not even light can escape, and as you fall in, you become part of it. Your physical body is destroyed, disintegrated. The ultimate horror of spaghettification isn't just the slow process of being stretched, it's the knowledge that it's happening. You wouldn't black out, you wouldn't pass out, you'd feel every second, every inch of your body being drawn into the black hole's gravitational field. And no matter how far you go, you can't escape it. This is why black holes are often called the ultimate cosmic killing machines. There's no mercy, no escape. The end is not quick. It's not painless. It's the slowest, most terrifying way to be destroyed in the entire universe. This is the true nature of spaghettification, and yet we're drawn to it. We study these cosmic horrors, not because they're fun to think about, but because they force us to confront the edge of our understanding, the edge of everything we know about physics. It's not just death we're studying, it's the end of the universe as we understand it. And in the case of spaghettification, that end is slow, painful, and utterly unavoidable. So, the next time you think about black holes, remember this. They're not just these empty, dark spots in space. They're monsters waiting for their prey. And if you get too close, you won't just be lost. You'll be stretched, torn apart, and erased from existence in ways that defy anything we can truly understand. That's the fate of spaghettification. That's the fate of everything that dares to fall in. The great attractor, what's pulling us in? There's something out there, something pulling our entire galaxy and everything around it toward a place we can't see. We know it's there because the numbers don't lie. The Milky Way is moving fast, not drifting, not wobbling, racing, over 600 kilometers per second, heading straight toward something. But here's the weird part. We don't know what that something is. We don't even have a clear picture of it. It's like trying to find a shadow in the dark. Something massive is hiding behind the thick band of our own galaxy, in a region of space that's almost impossible to observe directly. But it's there, and it's pulling us in. Astronomers call it the great attractor, because that's exactly what it seems to be. A massive, invisible gravitational force dragging entire galaxy clusters across the universe like they're nothing but dust in the wind. Now, let that sink in for a second. It's not just the Milky Way that's being pulled. It's not just our neighboring galaxies. We're talking about hundreds of thousands of galaxies, each filled with billions of stars, moving together in the same direction. That's an unimaginable amount of mass, all heading toward one point. A place we can't see. A place we can't explain. A place we didn't even know existed until the late 1970s. It all started when astronomers were studying the cosmic microwave background, the faint afterglow left behind by the Big Bang. They expected the radiation to be uniform in all directions, but it wasn't. There was a tiny imbalance, a slight temperature difference. One side of the sky was warmer than the other. That was the first clue. At first, they thought maybe the equipment was off, maybe it was a glitch. But after checking and double-checking, it became clear. Our galaxy is moving, and not just a little. It's speeding through space at hundreds of kilometers per second, and that motion needed a cause. That's when they started tracing the flow of galaxies in our region of space, and the results were eerie. Everything seemed to be heading toward the same general area, in the direction of the constellation Centaurus, about 200 million light-years away. But when they looked closer, there was nothing obvious there. No glowing cluster, no monster galaxy, nothing that could explain this much gravitational pull. That's when the name was born, the Great Attractor. It's a name that sounds like science fiction, but it's very real, and it raises some terrifying questions like, what could possibly have that much gravitational force? What's hiding in that part of space? And why can't we see it? The short answer? It's blocked. The Great Attractor sits in a part of the sky we call the zone of avoidance. It's an area that's almost completely hidden behind the dense gas, dust, and stars of the Milky Way's central plane. That makes it nearly impossible to observe with regular telescopes. It's like trying to see a lighthouse through a sandstorm. You know the light is there, but all the noise in front of it makes it impossible to spot directly. So for years, it was a mystery. We could measure its effects, but not the thing itself. A ghost in the data, a tug in the dark. But thanks to newer technology, especially X-ray and infrared telescopes. We've been able to peer deeper into that dusty region, and what we've found is wild. Behind all that cosmic fog is a massive concentration of galaxies. It's part of an enormous structure called the Norma cluster, and possibly even more than that. Some astronomers now believe the Great Attractor is just one piece of a much larger puzzle, a puzzle that includes another massive formation even farther out, the Shapley supercluster. The Shapley supercluster is one of the most massive structures ever observed, and it might be the real heavyweight behind this whole movement. Imagine an entire wall of galaxies, stretching for hundreds of millions of light years, and you start to get the picture. But even that might not be the end of it. See, the universe isn't just randomly scattered. It's structured. Galaxies aren't floating alone. They're part of clusters, and those clusters form filaments, and those filaments make up a vast cosmic web. It's like a giant network of matter stretching across the universe. And inside that web are nodes, regions where everything comes together, denser, heavier, more powerful than anything around them. The Great Attractor could be one of those nodes, or it could be something else entirely, something darker. Some scientists think dark matter is the key. We know dark matter makes up most of the mass in the universe, but we can't see it. We can only detect it by how it bends light and pulls on visible matter. If the Great Attractor is packed with dark matter, that could explain the enormous gravitational force without the need for a visible monster galaxy. Others believe it might be home to a massive concentration of black holes, possibly even merged supermassive black holes that have combined over billions of years. If that's true, then we're heading toward a region of space that's basically one big cosmic sinkhole, and the deeper we fall, the less we can see. Think about that. We're on a one-way trip, moving toward a gravitational force we can't fully understand. We don't know exactly what it is. We don't know what happens when we get there. All we know is that it's pulling us in. And here's what makes it even more unsettling. This isn't something we can escape. We're not steering this ship. Our galaxy is embedded in a current of space-time, a flow created by gravity and shaped by everything around us. And that current is pulling us towards something that could be the largest gravitational structure in the nearby universe. But don't worry, it's not happening tomorrow. At our current speed, it would take hundreds of millions of years to even get close. But the fact that we're heading there at all, that's the part that keeps astronomers up at night. It's a reminder that we are not the center of anything. We're not stationary. We're not safe. We are passengers drifting on a galactic tide toward a destination we still can't see clearly. And here's a question no one can really answer. What happens when galaxies reach the Great Attractor? Do they get absorbed into a larger structure? Do they pass through and continue drifting? Or do they collapse into some kind of hyper-dense region? Maybe even a kind of cosmic event horizon, where the flow of space and time itself begins to distort? No one knows, and maybe that's what makes it so terrifying. The unknown. The Great Attractor is like a cosmic riddle, wrapped in shadows. It challenges everything we thought we knew about how galaxies move, how the universe expands, and what might be waiting in the dark corners of existence. It's a reminder that for all our telescopes, for all our data, and all our theories, there's still so much we don't understand. We've mapped the stars, we've measured the background radiation, we've sent probes to the edge of our solar system, but we still don't know what's pulling us in. Maybe it's just a massive cluster of galaxies. Maybe it's a black hole big enough to warp the motion of entire superclusters. Maybe it's something we haven't even imagined yet, something that will force us to rewrite the rules of physics all over again. Whatever it is, it's real, and it's out there, and we're getting closer every second. What if black holes aren't the end, but the beginning? Let's flip everything you think you know about black holes. What if black holes aren't just the universe's trash compactors, devouring stars, swallowing light, and ending everything in their path? What if they're the opposite? What if black holes are actually gateways? It's a wild idea, But some of the smartest scientists out there think it might be true. And once you hear it, you'll never look at the universe the same way again. See, when two black holes collide, they release a ridiculous amount of energy. Gravitational waves ripple through space, bending it, shaking it. These aren't tiny ripples. They're real distortions in the fabric of the universe itself. Now, imagine what would happen if all the black holes in the universe, every single one, eventually merged together into one final, giant monster. Some physicists believe this could cause something called a cosmic bounce. Think of it like this. The universe is expanding right now. Galaxies are moving away from each other. Space itself is stretching. But one day, that might stop. Gravity could win. Everything could collapse in on itself. And just as it reaches total collapse, boom! A new universe explodes out of the ashes. It's like hitting the reset button on reality. The Big Bang happens again. A new universe is born, with new laws, new galaxies, and maybe even new versions of us. That's one theory. But it gets even crazier. Some scientists believe that every single black hole might already contain its own universe. Inside that terrifying singularity, beyond the event horizon where nothing escapes, could be a whole new cosmos, a baby universe sealed off from ours. Time and space flip. What looks like an end from the outside might be a beginning on the inside. Let that sink in. You could be living inside a black hole right now, and you wouldn't even know it. And if black holes can hold entire universes inside them, that means the universe we live in, everything we've ever known, might be the inside of someone else's black hole. It's a nesting doll of cosmic proportions. Universes inside black holes. Inside universes inside black holes. Infinite layers. Infinite possibilities. Then there's the wormhole theory. The idea that black holes could connect distant parts of space and time through tunnels. You enter one side and instead of getting crushed, you emerge somewhere completely different. Maybe in another galaxy, or maybe in another universe altogether. Now, this all sounds like science fiction, right? But here's the thing. Science fiction has a habit of turning into science fact. And this is where we bring in Interstellar, a movie that didn't just entertain, but introduced millions of people to the idea that black holes could bend time and space so much they might be our only ticket to other worlds. In Interstellar, the main character, Cooper, falls into a black hole, and instead of dying, he ends up in a 5-dimensional space, able to reach back through time to save his daughter. The black hole isn't an end, it's a bridge. Now sure, it's just a movie, but the science behind it? That came from real physicist Kip Thorne, who helped make the film as accurate as possible. The time dilation, the wormhole, the tesseract, those aren't fantasy. They're real theories based on Einstein's equations. So maybe black holes aren't the end of the story. Maybe they're the turning point. Maybe, just like in Interstellar, what looks like death is actually our next beginning. Well, you see, black holes are monsters, but they're also more than that. They're not just destroyers. They're cosmic puzzles, tightly wrapped in gravity and sealed with mystery. In the heart of every black hole lies a contradiction, something science can't fully explain. A place where space collapses, time slows to a crawl, and the laws of physics stop working the way we know them. They don't just bend reality, they break it. We used to think black holes were the end of everything. But now, more and more scientists are starting to wonder if they're actually the beginning of something else. Because here's the strange part. The more we study black holes, the more they seem to hold the answers to everything we don't understand. Time, space, matter, energy, the shape of the universe, the death of stars, the birth of galaxies, and maybe even the start and end of the entire cosmos. Think about it. Every galaxy we've ever studied has a massive black hole at its center, including ours. Why? Are black holes just a byproduct of galaxies? Or are they the architects? Do they grow inside galaxies? Or do galaxies grow around them? Then there's the question of what happens inside, beyond the event horizon, past that invisible boundary where nothing escapes, not even light. We can't see it. We can't send probes into it. We can't even agree on what's there. A singularity, a wormhole, a doorway to another dimension, or a place where time doesn't just slow down, but stops altogether. And what about the idea that every black hole might contain a new universe, that inside each one, the rules reboot, and something entirely new begins? If that's true, our universe could be the child of some ancient black hole that collapsed billions of years ago in another reality. Black holes don't just challenge science, they challenge us, our understanding, our imagination, our place in the universe. They are silent, they are invisible, they are unstoppable, and they are out there, waiting. But here's the real question we still don't have an answer to. What if the scariest thing about black holes isn't what they destroy, but what they might become? Subscribe